Hi everyone, welcome back. Today we're doing final value of variable after performing operations but in Java. So this question is a great question for understanding the quirks of Java. To be specific, we'll be looking at how we'll be comparing two strings together using Java equal function over here. So for this question, we're given a programming language with only 4 operations and one variable x. And these two string permutations will increment the value of the variable x by 1, and these two will decrement the value by 1. So initially the value of x is 0, and we have to iterate through all strings in operations and return the final value of x after performing each operation on x. So in this case, for example, if we are given the first step to decrement it, followed by 2 steps to increment it, after decreasing the value by 1 and incrementing the value by 2, x will be equals to 1. For the second example, we are given 3 operations to increment x. So in this case, this gives us 3. And for the final example, we increment x by 2 times and we decrement it by 2 times. So this gives us 0. For the constraints, the operation will have up to 100 items, and there's a minimum of 1 operation. And every operation will be either 4 of these permutations. So this question is pretty simple enough such that we do not really need to trace it to understand how it works. So the first step will be to define a variable x. And for our viewers who come from the land of snakes, who use Python, please don't forget to put semicolons after your statements. Personally for me, I use Python all the time at my job, so I personally feel a bit of brain damage as I'm recording this right now. But for every single one of these operations in this array of strings, we're going to iterate it with a simple index. So to use a for loop, index equals to 0, index less than operations.length, and index plus plus. So let's break this for loop down a little bit so that it's clearer how it works. So in this statement in the for loop, the first statement that is separated by this semicolon over here is to define a variable that will be used in this for loop. The second statement in this case is the condition for whether if this for loop should run. And the final statement over here indicates any mutation logic that we would like to do at the end of every iteration. So to be specific in this case, index plus plus means that use the index, and after this loop has finished, increment index by 1. So this is pretty much having the overall effect of iterating index from 0 to the final index of operations.length. So using this index, we can get the string at every single position. So let's call this string operation equals to operations at this index. So this is how we would access an item in an array of strings. And the next step will be to check whether if this operation is equals to addition operator or a decrement operator. And this is frankly where I messed up for the first time when I was doing this question. This was not my first take for this video, by the way. But if we wish to compare two strings together, unlike in Python where we just do double equal signs and that allows us to compare by value, the double equal operator over here in Java is comparing by reference. So what this means is that and in this case in Java, every single string is really an object of type string. So what this means is if you compare two objects together with the equal sign, you are comparing by memory reference. So even if two strings have the same value, they are not going to be the same. So to prove that to you, I'm going to give you a simple demonstration. So system out print line operation and let's say operation, and let's try comparing that with this, let's say this operator like this. So let's try running this code and let's see what we get. Okay, I just mentioned we should always put semicolons after every statement, but I guess I breached that advice there. Yes, of course, we have to return something here. In this case specifically, you need to return an integer. So let's return an integer like this. Should I just return x for now? This will give us a wrong answer, but the objective is to compare these two statements over here. I'm embarrassed. Let's run this again. Okay, so as you can see, okay, this is not a great example. Let's change this string to one of the test cases over here. And for our viewers who are used to Python or other languages that allow string comparison with two equal signs, you might expect these two statements over here to be true if we change line 8 to compare with x++. But if you run this again, you will be surprised to find that these two statements are actually false. And that's because operations in this case, this comparison over here between these two strings are comparing by memory reference rather than the value itself. So if we want to compare two strings together in Java, we will use the equal method on the string itself. So equal over here is a function that's under string objects. So let's try running this again. Okay, sorry, it should be equals, I guess. Let's run this. And you can see this time the comparison is correct as expected. So this is a little quirk that is very important for our software engineers who are developing in Java. Remember that when you compare two strings together, please use the equals method to compare two strings together instead of using double equal signs. So let's proceed on with this question. If operation equals x++ or operation equals ++ x, then we will increment x by 1, else we decrement it. So this branch will be visited by the scenario when each operation is negative x or x negative. So let's run this code again, and this time we should pass the test cases. Okay, that's very embarrassing, but I hope this was a good reminder to myself that we should put semicolons after every line. Okay, so this passed. Let's submit this. And there we go. So let's go through the time and space complexity for this solution over here. So in this case, for the time complexity, if we let n be n is the length of operations, then in this case the time complexity will be O(n), because understandably from line 10 to line 17 we're iterating through every single item in the string array. So what this means is, as your operations scale, the runtime for your solution over here will scale as well. And for the space complexity, in this case we are using a constant number of variables, and each variable over here doesn't scale linearly with operations. So space complexity in this case is O(1). So I hope this was a clear explanation, and hopefully this was a good practice for you on the main concept that if we want to compare strings, please use the equals method over here to compare strings. So that's about it. I hope to see you again, and see you in the next video.